This video demonstrates the work done in XR 5.0 Pilot 1. Pilot 1 has two use cases, 1.1 and 1.2, with HoloLight developing the XR app. Demo setup has the following: a PC with NVIDIA GPUs running HoloLight Space application and a Microsoft HoloLens 2, a connection to KUKA remote service and the integration of Siemens AI services, and IML's Unity plugin integration. Once the setup is complete, let us now connect the client to the RoboSpace application. Once the connection is established, we can load the step file by drag and drop feature. A loading cube appears and it can be placed anywhere in your real space. The hand menu has three main functions apart from the RoboSpace main menu. The app lets users preview model loading and provides several alignment options such as align to the ground. Select the check mark for the model to load in your space. Now, we will see the demo of AR overlay. Starting with the explosion view of the KUKA robot model. The technician uses the explosion feature from the Tools menu and is now able to see the inner components of the model, enabling them to prototype and review effectively. You can also see how the technician, within the small screen, will use a cross-section feature, using a cube, to study and analyze the components of the robot model. The user is freely walking around the virtual model in their real space, allowing for a 1:1 overlay in AR. The technician will now use the main overlay alignment feature. It is a two-point alignment method. First, the technician selects the virtual object anchor, in red, and freely places it on the virtual model. Then, the user selects the real-world anchor, in blue. Here we use the edge of a table. After placement and confirming the alignment, the edge of the virtual model and real-world edge align and you have an AR overlay. We will now visualize the real-time sensor data from the KUKA robot via the remote service. First, we enable the remote connection to the robot via VPN. And now we will visualize the real-time data directly on the virtual robot. Clickable icons hover over the sensors and the technician selects them to see the real values. Upon disconnection, all the values appear in red, indicating the bad connection status. We also have the first version of voice commands, a native app feature which enable users to interact with the UI using their voice.
Hey KUKA, distance 1.
Here the user is prompting the system to display the distance sensor data through voice interaction. Let's move to the training program demonstration. Here we are seeing the training program created for simple robot movement. More specifically, a guide on using the KUKA Smart Pad. It is a training program with 3 steps. Each step has a description and may have a training material attached to it. Here we see the training material is an image which can be opened in the mixed reality environment. This helps technician train and learn about the KUKA Smart Pad usage along with the 3D model of the robot. The panels for the training material are freely movable in space, allowing users to learn with the 3D model as reference. Now we will see the AI in action. The KUKA bot is available as an AI chatbot on the hand menu.
Show me the photo of KUKA KR10.
We use the speech-to-text and text-to-speech service of Siemens. The KUKA bot acts as a chat assistant and queries PDF manuals and training materials for the technicians to enhance their training.
The KUKA KR10 1100-2 industrial robot is depicted in Figure 1. This is a 6-axis articulated robot arm.
Give me the page 7 of the S7 PLC.
Page 7 of the datasheet manual for the 7 PUK. KU1515-2 details system tools and data management resources. It highlights the manual collection, My Documentation Manager, and the CAX Download Manager, as well as introducing the Chia selection tool.
Here we see how a KUKA robot is integrated into the XR 5.0 Claudite platform. It starts with describing the robot, its static and dynamic properties. That data is packaged into an AASX file, then loaded into the runtime environment. Once deployed, it shares data with the platform, connecting the physical robot with its digital counterpart, providing real-time visibility into its state and behavior and performance. Hope you enjoyed Pilot 1 demo. Thank you for watching.